pottery kiln breaker tripping can be frustrating, especially when it disrupts the firing cycle. Here's a breakdown of potential causes and troubleshooting steps. One possible reason is high starting current. Kilns often draw a significant current surge when the heating elements are initially activated. Ensure the breaker is adequately rated to handle this peak current. You might consider using a breaker with a higher interrupting capacity if the existing one is marginal. Another common issue is loose or faulty connections. Thoroughly inspect all electrical connections, including those at the breaker, within the wiring, and at the kiln terminals. Make sure everything is tight and properly insulated. Loose connections can lead to arcing, overheating, and ultimately, breaker tripping. Overheating of the kiln itself can also cause the breaker to trip. Monitor the kiln's temperature during operation. If it consistently exceeds the manufacturer's specifications, there might be an issue with the kiln's control system or cooling. A faulty kiln element is another potential culprit. A damaged or malfunctioning heating element can draw excessive current, causing the breaker to trip prematurely. Testing the elements with an ohmmeter can help identify this issue. In a 240-volt circuit, the neutral wire plays a crucial role. While it ideally carries minimal current in a balanced 240-volt load, any imbalance can cause current to flow through the neutral. Ensure the neutral wire is properly sized and has the same ampacity as the phase wires. A voltage imbalance between the phases can also lead to uneven current distribution and breaker tripping. Use a voltmeter to verify the voltage balance at the kiln. Significant voltage differences between phases can overload one leg and cause the breaker to trip. Make sure the breaker is the correct type for the circuit. Typically, a thermal-magnetic breaker is used for standard overcurrent protection. However, in some cases, a ground fault circuit interrupter breaker might be required, especially if there's a risk of current leakage to ground. Ensure the installed breaker matches the requirements of the kiln and any applicable electrical codes. If other electrical devices share the same circuit as the kiln, they may contribute to breaker tripping. Disconnect non-essential loads to isolate the issue and determine if the kiln is the sole cause of the overload. When troubleshooting, begin by checking the breaker rating. If it's lower than the kiln specified amperage, replace it with a higher rated breaker that meets the manufacturer's recommendations and local electrical codes. Next, carefully inspect and tighten all electrical connections. Pay close attention to wire nuts, terminal screws, and any other connection points. Loose connections can create resistance and generate heat, leading to breaker tripping. Monitor the kiln's temperature during operation. If you notice any signs of overheating, investigate the cause and take corrective action. This might involve adjusting the kiln's settings, improving ventilation, or repairing faulty components. Use an ohmmeter to test the kiln elements for resistance and continuity. Compare your readings to the manufacturer's specifications. If an element shows significantly lower resistance or a lack of continuity, it's likely faulty and needs replacement. Verify the neutral wire size and ensure it matches the ampacity of the phase wires. If the neutral wire is undersized, replace it with a properly sized wire to prevent overheating and potential breaker tripping. Use a voltmeter to check the voltage balance at the kiln. Ideally, the voltage between each phase and neutral should be equal. If you find a significant imbalance, investigate the cause and take steps to correct it. Consider installing a dedicated circuit for the kiln if it's sharing a circuit with other electrical loads. This can prevent overloading the circuit and tripping the breaker. Make sure the breaker type is correct. A standard thermal magnetic breaker is usually suitable for kiln circuits. If you're unsure, consult with a qualified electrician to determine the appropriate breaker type. If the issue persists after following these steps, it's best to contact a qualified electrician for further diagnosis and repairs. They can perform more advanced testing and identify any underlying electrical problems that may be causing the breaker tripping. Remember to always prioritize safety when working with electricity. If you're not comfortable performing any of these troubleshooting steps, seek professional assistance. Here are some additional points to consider. Check the ambient temperature of the room where the kiln is located. High ambient temperatures can affect the breaker's performance and cause it to trip prematurely. Ensure there's adequate ventilation around the kiln to prevent overheating. Inspect the breaker panel for any signs of damage or corrosion. If you notice any issues, consult with an electrician to have the panel inspected and repaired. Check the voltage at the breaker panel to ensure it's within the acceptable range. Low voltage can cause the kiln to draw more current, potentially leading to breaker tripping. Verify that the wiring between the breaker panel and the kiln is properly sized and in good condition. Undersized or damaged wiring can create resistance and cause overheating. Consider using a clamp meter to measure the current draw of the kiln while it's operating. This can help you identify any excessive current draw that may be causing the breaker to trip. Check the kiln's control system for any malfunctions. A faulty control system can cause the kiln to overheat or draw excessive current. If the kiln has a built-in timer, make sure it's functioning correctly. A malfunctioning timer can cause the kiln to run longer than intended, potentially leading to breaker tripping. Inspect the kiln's thermocouples for any damage or wear. Faulty thermocouples can provide inaccurate temperature readings, causing the kiln to overheat. If the kiln has a ventilation system, make sure it's working properly. A malfunctioning ventilation system can cause the kiln to overheat. Check the kiln's door seals for any damage or wear. Damaged door seals can allow heat to escape, causing the kiln to work harder and draw more current. Consider using a surge protector to protect the kiln from voltage spikes. Voltage spikes can damage the kiln's components and cause the breaker to trip. Keep the area around the kiln clean and free of debris. Dust and debris can accumulate on the kiln's components and cause them to overheat. If you are using a kiln that's been stored for a long period of time, have it inspected by a qualified technician before using it. Stored kilns can develop electrical problems that can lead to breaker tripping. Consult with the kiln manufacturer for specific troubleshooting recommendations for your model. The manufacturer may have encountered similar issues and have specific solutions. Keep a log of any breaker tripping events, including the date, time, and kiln settings. This information can help you identify patterns and potential causes. If you're unable to resolve the breaker tripping issue yourself, don't hesitate to contact a qualified electrician or kiln technician for assistance. They have the expertise and equipment to diagnose and repair complex electrical problems. Remember that electrical work can be dangerous. Always take precautions to protect yourself from electrical shock. Turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate safety gear. If you're not comfortable working with electricity, hire a qualified electrician to do the work. By following these troubleshooting steps and taking appropriate safety precautions, you can often resolve kiln breaker tripping issues and keep your kiln running smoothly. If the issue persists despite your best efforts, don't hesitate to seek professional assistance. They will be able to properly diagnose the issue and perform repairs to keep you and your equipment safe. Always ensure that any electrical work complies with local electrical codes and regulations. This will help to ensure the safety of your installation and prevent future problems. Breaker tripping can be frustrating, but with a systematic approach and attention to detail, you can often identify and resolve the underlying cause. Remember to prioritize safety and seek professional assistance when needed. Good luck with your pottery projects.